Alright, May 10th through 14th, this is lesson 37. We are going to be looking at a surprising boost from geometry. Alright, today we define a new number system that allows us to identify solutions to some equations that have no real number solutions. The complex numbers, as you will see, in fact, share many properties with real numbers with which you're familiar. We're going to be taking a geometric approach to introducing complex numbers. Alright, so let's go ahead and look at, the first 4 questions on your classwork should be pretty simple, but it says solve each equation for x. So looking at A, what would I do? To solve for x, I would go ahead and add 1 to both sides of the equal sign. So I get x is equal to 1. Alright, looking at B, I would subtract 1, and I get x is equal to negative 1. C, I would add 1 to both sides. I get x squared is equal to 1. We know that in order to solve for x, we would take the square root. So in this case, the square root of 1 would be 1 or negative 1. So there are 2 solutions here. Alright, and then the last one, subtract 1, and we get x squared is equal to negative 1. So we know that we can't take the square root of a negative number, so there are no real solutions here. Alright. So now, before we go on to the rest of the lesson, let's kind of talk a little bit about a few things. Alright, so I want to talk about what happens when I multiply by negative 1. Alright, so let's just kind of look at a number line here. This is our standard number line. We've got 0, 1, 2, 3, 4, 5, and then negative 1, negative 2, negative 3, negative 4, negative 5. Okay, so let's talk about what happens when we multiply something by negative 1. Let's say that I want to start with 2, and I want to do 2 times negative 1. Well, what that does is 2 times negative 1 is negative 2. And that is what we call a 180-degree rotation. Alright? If I multiply negative 2 times negative 1, I get positive 2. Once again, that is a 180-degree rotation. When I multiply a number, or when I multiply something by negative 1, it rotates the number line in a plane by 180 degrees around the point 0. Alright? So here's my question. Is there a number that we can multiply by that corresponds to a 90-degree rotation? Alright, so you might find this to be a strange question, but if I have a 90-degree rotation, the number line does not take on, the number doesn't take on the number line itself. So we have to imagine another number line that is a 90-degree rotation of the original. Alright, because if I flip something 180 degrees, then this number line is going to flip back onto itself. But if I want to flip this 90 degrees, now I have to imagine another number line. So this is a real number line. meaning all of the numbers here are real. So here's 0, and I'm just going to kind of sketch out a couple of things here. Alright, if I want to do a 90-degree rotation around the point 0, I now have to imagine another number line. So now this is the number line rotated by 90 degrees. Okay? Alright. So this, let's kind of think about this. So if I want to rotate 2 by 90 degrees, it's going to rotate here into something. If I want to rotate 4, it's going to rotate here into something. Alright? If I want to rotate -2, it's going to rotate here into something. Alright, by 90 degrees. If I want to rotate -4, it's going to rotate here into something. Alright? This looks like a coordinate plane. However, how should we label the points on our vertical axis? Well, since we imagined such a number existed, let's call it the imaginary axis and subdivide it into units of something called I. Alright, so I'm going to label this I, well actually this would be I, 2I, 4I, this would be -2I, -4I. Alright, so we have this imaginary number. Alright, so if I rotated 1 90 degrees, it would rotate to 1 times I, which is 1I. Alright, so this would be 2 times I. This would be 4 times I. Alright? What happens if we multiply a point on the vertical number line by I? Alright, so let's talk about what happens if I'm going the opposite way. Alright, so once again I have my number line here. Okay. And then I have, we said this was I, this was -I, -2I, 2I. Alright? So I want to know now what happens if I multiply a number on the vertical axis times 1, or by I. Alright? So let's kind of think about this for a second. What if I want to do it like this? Now I want to go from here to here. I want to go from here to here. Instead of going from my real numbers to my imaginary numbers, now I want to come from my imaginary numbers to my real numbers. Alright, so here, alright, so here I would be multiplying I times I, 2I times I, 3I times I. Well, let's think about that. what is I times I? I times I would be I squared. All right? I'm going to take this off. I'm going to concentrate more on this right here. I want to come from my vertical to here. This would be, we'll just go up here. This would be 3i times I. Well, that would give me 3i squared. But where does it take me? All right? What if I do negative 3i times I would give me negative 3i squared. But where does it take me? When we perform two 90-degree rotations, it's the same as performing a 180-degree rotation. So multiplying by I twice results in the same rotation as multiplying by negative 1. Since two rotations by 90 is the same as a single rotation by 180, two rotations by 90 is equivalent to the multiplication of I twice, and one rotation by 180, which is equivalent by the multiplication of negative 1. So, if I have I squared times a number, that is the same thing as saying negative 1 times x. So, no matter what, here's what we know about I squared. I squared is always equal to negative 1. Well, why might this new number be useful? Well, if you recall from the opening exercise, we had a problem that looked like this. All right? We said that there were no real solutions because I could not take the square root of a negative number. However, because we know that I squared is equal to negative 1, let's think about this. So if I take the square root of this, I would get the square root of negative 1 or the negative square root of negative 1. All right? Because we know square root can be positive or negative. All right, so since I know that I squared is negative 1, all right, I squared is equal to negative 1. And since I know that the negative I squared would be equal to, that would be negative 1 squared, I squared, which would be negative 1, we have two solutions for our expression now. All right? And that would be that this could be I, and this would be negative I. All right? So, we know that now the square root of negative 1 is I, because I squared is equal to negative 1, and the square root of I squared is I, so therefore I now have two solutions to my problem. Alright? Alright, so now let's kind of talk about a problem. If you remember back in Algebra 1, if we had something that we could not factor, then we would apply the quadratic formula to it. Alright, so let's say that I had x squared plus 2x plus 5 is equal to 0. Well, this can't be factored, so if you remember, we would do the quadratic formula. So x would be equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2a. Alright? So when I figure all of this out, we would get that x is equal to negative 2 plus the square root of negative 16 over 2, or that x is equal to negative 2 minus the square root of negative 16 over 2. Alright? So at this point in time, we would have said, well, there's nothing we can do because we can't take the square root of a negative number. Now we have our imaginary numbers, and we can do the square root of a negative number. Now we can rewrite the square root of negative 16 as the square root of 16 times negative 1. Alright, and then our properties of square roots tell us that I can now do the square root of 16 and the square root of negative 1. Alright, well, the square root of 16 is 4, and the square root of negative 1, think about it, negative 1 is I squared, so this would be I squared. The square root of I squared would be I. So now I can say that it is 4I. Therefore, we can now plug back in. X would be equal to negative 2 plus 4I over 2, and I can reduce that to negative 1 plus 2I, just dividing everything by 2. And then I would get x is equal to negative 2 minus 4I over 2, which is negative 1 minus 2I. So now I can say that I do have solutions to my equation. And the solutions are negative 1 plus 2I and negative 1 minus 2I. The solutions are what we call complex numbers. Alright, complex numbers. Alright, and we can locate those in what we call the complex plane. Alright? So if I look at a complex plane, these are our real number solutions. Alright? Our real numbers are here. And these are what we call purely imaginary numbers. Alright? So, I've got 1, 2, 1, 2, negative 1, negative 2. Oh, nope, that would be negative I, negative 2I. This would be I, and this would be 2I. So I could say that negative 1 plus 2I would be right here. Alright? And then negative 1 minus 2I would be here. So I can plot these on a coordinate plane. Alright? So what you need to know is that all complex numbers can be written in the form A plus BI. Alright? A plus BI. where A and B are real numbers. All right. Just as we represent real numbers on the number line, we can represent complex number lines or complex numbers on the number line. And like I showed you here, I would just take the first part, which is -1, and go to 2i, -1, go to -2i. All right? So let's go back to our classwork and see what we can do with this information. So it says compute 3 plus 4i plus 7 minus 20i. Okay, so here's what I'm going to show you. If I have a problem that looks like this, and I'll just write it here. If I have a plus bi plus c plus di, where a, b, c, and d are real numbers, okay? Then what I can do is I can pull out the a and the c, and then I can do b plus d times I. Alright, so let's use that. Alright, so I can do my A and my C. So this is A, B, C, D. Alright, so I can do 3 plus 7 plus 4 minus 20 times I. Alright? So now I can do 3 plus 7 is 10 plus 4 minus 20 is negative 16 times I. So I could rewrite it 10 minus 16I. And that's how simple it is. Alright, let's look at example number 2. Subtraction with complex numbers. I'm going to do it very similar. It just changes a little bit. Alright, so let's look at this, and we're still going to pull our, here's what I would suggest you do. I would suggest you distribute your subtraction sign and rewrite it as an addition problem. So 3 plus 4i plus negative 7 plus 20i. I think that's going to be easier for you to make sure you keep the signs correct. Alright, so now let's do 3 minus 7 plus 4i plus 20i, which I should have pulled the I out. Alright, so 3 minus 7 is negative 4, plus 4 plus 20 is 24i. Alright. Hopefully it's not too difficult. Hopefully you get it. I don't think it's really hard. Alright, how do I multiply with complex numbers? Well, I'm going to write it right here. A plus bi times c plus di. Alright, so if I'm multiplying these numbers, then I'm going to multiply a times c plus b c I plus a d I plus b d I squared. So guys, I use the exact same thing. Multiply, 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 multiply. Alright? Now we've got a couple of things that we're going to look at as we do this. So using the 1 plus 2i times 1 minus 2i, let's multiply. 1 times 1 is 1. 1 times negative 2i is negative 2i. 2i times 1 is positive 2i. And 2i times 2i, or times negative 2i, is negative 4i squared. Now, here's where it's getting tricky. You got to be careful. So I can go ahead and combine my like terms. Well, negative 2i and 2i cancel. So I get this. We learned just a little bit ago that I squared is equal to what? I squared is equal to negative 1. So, look. I'm going to plug negative 1 in there, and I get 1 plus 4. So, my answer is 5. I don't even get a complex number when I multiply this. Alright? Alright, multiplication with complex numbers. Verify that negative 1 plus 2i and negative 1 minus 2i are solutions for this. Alright, so how do I do that? Well, I'm going to plug them in. So they're telling me that this is what x is equal to. Alright, so let's do negative 1 plus 2i. Alright, so negative 1 plus 2i squared plus 2 times negative 1 plus 2i plus 5 should equal 0. Alright, hopefully. Alright, so we got to multiply. So negative 1 times negative 1 is 1. Negative 1 times 2i is negative 2i. 2i times negative 1 is negative 2i. And 2i times 2i is 4i squared. 2 times negative 1 is negative 2. 2 times 2i is 4i. Plus 5 is equal to 0. Alright, let's go ahead and combine what we can. So I get 1 and negative 2 is negative 1 and 5 is 4. Alright, so that takes care of all of that. Negative 2i and negative 2i is negative 4i. And then I've got a positive 4i, so those cancel out. And then I've got plus 4i squared is equal to 0. Now, what do I know that I squared is equal to? Negative 1. So 4 plus a negative 4 equals 0. 0 is equal to 0. It works. Alright? Now we're going to verify that negative 1 minus 2i is a solution. Same way, negative 1 minus 2i squared plus 2 times negative 1 minus 2i plus 5 is equal to 0. Alright, let's multiply. Negative 1 times negative 1 is 1. Negative 1 times negative 2i is a positive 2i. Negative 2i times negative 1 is a positive 2i. And negative 2i times negative 2i is a positive 4i squared. 2 times negative 1 is negative 2. 2 times negative 2i is negative 4i. Plus 5 is equal to 0. Go ahead and combine your like terms. So 1 and negative 2 is negative 1. Negative 1 and 5 is 4. 2i and 2i is 4i, and I have a negative 4i that cancels out. So I'm left with this. Alright, we know that I squared is equal to negative 1. So I get 4 minus 4 is equal to 0. 0 is equal to 0, and it checks out. Alright, so I will tell you that you will use complex numbers, not just in Algebra 2, but continuing on into higher math. So this is your introduction to complex numbers. So now we no longer can say, I have no real number solution because I can't take the square root of a negative number. Alright guys, hope you have a great rest of the day, and we'll see you for the next lesson.